Hi everyone, wastewater engineering processes SRT calculation. Last time we introduced what SRT is and just solve a simple example in terms of SRT calculation. I will provide you with the link to that video if you mind. And in this example, we just solve a bit more interesting and a bit more trickier example. We In our wastewater treatment, we have like an aeration basin, which the volume of the tank is 10,000 US gallons, and the concentration of biomass inside the aeration basin is 1500 milligram per liter. The amount of wastewater discharge coming to our planet after screening and grid chamber is 25,000 gallon per day of wastewater, and then it just goes to secondary clarifier. A part of it, a big chunk of it is treated. That's Q discharge effluent. Treated wastewater, we call that treated wastewater. And then recycled flow rate is 500 gallon per day, which 500 of that 5,000 is wasted. So it just says over here, discharge is about 5,000, dissects into two part. One portion returned back like activated sludge to aeration basin, that's 4,500, and 500, it just goes out of the system, 500 gallons. It just wasted. That's wasted. This is recycled. And we want to calculate solid retention time. So we do know the SRT, or theta sub c, is equal to this equation. Let's make it a bit cleaner. So if this is the recycled and this is wasted and this is treated and this is initial flow rate of sludge. So we do know the volume of the tank, which is 10,000 gallons, concentration of aeration basin in terms of biomass, that's 1500 ml in terms of MLSS, mixed liquor suspended solid. In denominator, Q wasted is 500, Q effluent, we don't know. Concentration of the treated, like XE is equal to 30 mg per liter. And if you compare this one to the concentration of the initial biomass, which is 1500 milligram per liter, you can see how the biomass is reduced in after treatment. So that's from 1500 to a biomass of 30 milligram. That's a treated wastewater, and that's a good point. And then the concentration of wasted, which is not known, this is like 30. So we have to look for Q effluent first and then concentration of waste. Then if you simply plug them back into SRT calculation, you can solve an interesting problem in FE&P exam related to SRT calculation. So let's see how we can approach this problem. So let's have a better look to our initial aeration tank and also the secondary clarifier. And if we just look at the schematic Q not come to the aeration basin, then just move to secondary, part of it, a big chunk of it treated, a small portion of it wasted, and a bigger chunk of uh, material here is just recycled. So if we just call this, and after the first cycle, we have like Q return plus Q not coming back to secondary and keep the activated sludge in return to get a better and better treatment. A So Q naught is 25,000 gallon, Q recycle 4,500, Q waste is 500, and in after one cycle, Q recycle discharge added up to initial Q and goes to secondary clarifier. And in terms of if we create a control volume in around the secondary clarifier and use the mass balance equation, we can get our unknowns. So we call the concentration of biomass coming is X, like in inflow wastewater, and XE concentration of biomass in treated one, concentration of biomass in wasted, and this is XW as well because the concentration of here it's the same part of it wasted and it just dissect into two parts, part of it waste and part of it just recycled. So XR and XW is the same. Let me make it a bit cleaner. So if a problem statement gives us the concentration, initial concentration of biomass from aeration tank. So here concentration of biomass was 1500 milligram per liter of biomass inside the aeration basin. It just comes to secondary clarifier. X, X sub E is 30 milligram per liter for treated wastewater. We do not know what XR or XW is, and also we do not know what the Q of effluent is. These are not, so we have to calculate a QE and then XR, plug it back in SRT calculation. Let's see how we can do that. So by having our control volume with around the secondary clarifier, we can easily say the Q in should be equal to Q out. Whatever comes to the secondary clarifier should be equal to what goes out. So times their concentration, consider that one as well. So X, the concentration of incoming flow rate plus recycled minus the Q recycled times the, so this is coming to our secondary clarifier. This is going out, this is going out, this is going out. So one portion coming in, so this is plus, and these are 1, 2, 3. They are subtracting, and the equation should go 0 because we should have a mass balance in our control volume. So first of all, the first unknown is Q effluent. You can easily say whatever comes to the system is just like in a closed circle except what is wasted. So Q effluent, in the other terms, we can say all the wastewater comes to the secondary clarifier should be treated except what goes out of the system. So it just keep rotating until it just treated all of them. So but the one wasted, it just goes out of the system. So the initial flow rate Q naught is 25,000 minus the wasted one. The rest is recycled until it get cleared. So 24,500 US gallons per day is Q effluent. And then if you, and we already talk about why XR and XW is the same. So if we just replace the XW by XR in this part, we can easily say 1500, which is the concentration of biomass, times the Q naught, which is 25,000, plus Q return 4500, minus Q return times the concentration of return, minus Q waste times concentration of that, minus Q effluent, we just calculate that one, times the concentration which is provided, should goes 0. That if you solve this problem, it just gives us the only unknown, which is concentration of recycled or waste, which is 8,703 milligram per liter of biomass. So, and if we just plug that part in, equation of SRT in denominator here, you can easily calculate it. So as soon as we have X concentration of waste or recycled, which is this part, and plug it back in our equation, and replace other part. Volume is 10,000. Biomass concentration in aeration is or coming to secondary is 1500. Q waste 500. Concentration, we just replaced it here, 8,703. QE 24,500 times the concentration, which is 30. And as soon as you replace them, it just gives you a solid retention or resident time within the system is 2.95, almost 3 days of solid retention time. Thank you. We'll solve more problems.